All right, so we're going to go ahead and take a look at finding the volume of spheres and cones. So if we look at the volume formula here for a sphere, we see that it's 4 over 3 multiplied by pi multiplied by the radius cubed. Now this isn't a formula that you would be able to figure out on your own necessarily. It's one that we're going to kind of have to look at quite a bit and possibly memorize. All right, so here we're looking at the first example. And it gives us 4 over 3 multiplied by pi, which we substitute in 3.14 for, and then we multiply it by the radius cubed. Now, when I'm cubing a number, for example, 2, that's going to be the same thing as multiplying 2 by itself and then multiplying it by 2 once more. So we have 1, 2, 3 2's here that we're multiplying together, so that is 2 to the third power, or 2 cubed. And when we multiply 2 times 2 times 2, it's going to give us 8. So we do 8 times 3.14 to get 25.12, and this is meters cubed. Multiply it by 4 over 3, and we're going to end up with 33.49 meters cubed. And notice you can do your multiplication by multiplying by 4 first before you divide by 3, or you could start off by just doing 4 divided by 3 and then multiplying that by 25.12. So either way you do it, it works because that 3 is on the bottom. All right, let's go ahead and take a look at the first problem that isn't done for us. Here we're looking at the formula for a sphere. So I'm going to highlight this in purple, even circle the shape in purple, so that way I know I'm talking about the volume of a sphere as opposed to a cone. And I'm going to write out the volume here in purple. 4 over 3 multiplied by pi multiplied by the radius cubed. So now we can go ahead and start substituting in for pi and the radius cubed. Volume equals 4 over 3 multiplied by 3.14 for pi multiplied by the radius cubed. Since our radius is 3 centimeters, we're going to do 3 times 3 times 3. 3 times 3 gives me 9, times another 3 is going to give me 27. So we have 27 centimeters cubed for the radius cubed. And now we have to finish this off by multiplying. 4 over 3, which you may have seen on your calculator, is 1.3333 repeating. And then we're going to multiply that by 3.14 times 27. That gives us 113 centimeters cubed. Go ahead and circle it. Nice rainbow pen. Boom. This is our answer. Put a star, smiley face, whatever you want to do. And we're moving on to the next problem. So again, here I'm going to start off by writing the formula. But notice this time we're working with a cone. Think about it as an ice cream cone if you flipped it upside down, or a traffic cone that you might see out on the road. And the formula for finding a cone is going to be highlighted here in green. And that is 1/3 times the height times pi times the radius squared. So let's go ahead and rewrite that formula. I want to do this problem in blue. Volume is 1/3 times the height times pi times the radius squared. And now we can go ahead and start filling in for these variables and for the radius. And so now we have 1/3 multiplied by the height of 9 meters multiplied by pi, which is 3.14, multiplied by the radius squared. Since our radius is 7, we're going to square it. Do 7 times 7, which gives us 49. So now that I have 1/3 times 9 times 3.14 times 49, I just need to multiply all of that together and see what it gives me. So in my calculator, I'm going to do 1 divided by 3 multiplied by 9 multiplied by 3.14 multiplied by 49. And it comes out to 461.58, and this is meters cubed. I can go ahead and circle this in my nice rainbow pen. to show that I have my final answer. All right, so now I have two more problems here. You're going to use the same formulas listed above. Maybe you want to make your spheres a certain color like I did with purple, and then I made my cones green just to separate the two formulas from each other. And then I always think it's beneficial to rewrite the formula before you start out. That way you don't make any mistakes, and that way you start to get that formula in your head. After you finish that first page, you're going to move on to the second page. Again, the formulas are listed here for your reference. And you only have 5 problems here. I always think about these cones as an upside down ice cream cone, right? Where you'd hold it. And so if it's the base, it's basically like finding, hey, how much ice cream could melt inside of my cone? All right, because that happens sometimes when we get a cone full of ice cream. I'm not complaining. I don't know about you guys, but thank you so much for watching, and let me know if you have any questions.